All right, so we're looking at question 6 from section 1.6. So we're getting into the second derivative. So we have a function, we're told a few of its properties, but only a few, and they're all centered around what happens with this function when x equals 2. So first thing we're asked, is f increasing or decreasing near x equals 2? So if you want to know if a function is increasing or decreasing, that information comes directly from the first derivative. So a function's derivative, or a function's first derivative, tells you what the instantaneous rate of change is for that function f at whatever point you're looking at. So we care about right now is what is f prime of 2, because we're asking if f is increasing near x equals 2. So we know that f prime of 2 is 1.5. Most importantly, that is a positive number. So that means that, so this implies that f is increasing. So positive derivatives indicate that your function is increasing at that point. All right. Also, is f concave up or concave down? So concavity is something that is quantified by a function's second derivative. So f double prime of 2, what do we know about that? We know that that is equal to negative 0.25. Most importantly, that is a negative number. So what does that mean? That means that f is concave down. So at this point, x equals 2, we know we have a function that is increasing, but it's concave down. So what does that mean? That means the rate at which it's increasing is decreasing. So subtle idea there, but it's an important one to make. So we know we have a function that maybe at this point it's increasing, so it has an upward slope, but it's concave down, which means this upward slope, it might be going from, steeper at the beginning to leveling off. Basically, that rate of increase is decreasing as we move from left to right. All right, part B, do we expect f of 2.1 to be greater than negative 3, equal to negative 3, or less than negative 3? So in our last part, we were talking about derivatives, which don't really have anything to do with the location of the function or what point exists on the function. So now we need this information. So f of 2 is equal to negative 3. So what do we expect to be the case at f of 2.1? Well, in part A, we answered that in this neighborhood around x equals 2, function f is increasing. So we would probably expect that if we increase our value of x a little bit by 0.1 units, then the value of y will increase by a little bit. So for that reason, we would expect f of 2.1 to be a little bit bigger than f of 2. And why is that? Well, because f prime of 2 is positive. Or if you want to, or equivalently, f is increasing at 2. All right, part C, do you expect f prime of 2.1 to be greater than 1.5, equal to 1.5, or less than 1.5? Okay, so we're being asked about the derivative at 2.1. We don't know anything about the derivative at 2.1, but we do know about the derivative at a nearby point. We know that f prime of 2 is equal to 1.5. So we expect, if we let x vary a little bit, or we let x increase a little bit, what do we think is going to happen to f prime? Well, we know that basically what we're asking is f prime increasing or decreasing, or do we know that? What is it that tells? So remember that f prime, the derivative of a function, is a function unto itself. So we can talk about f prime without really worrying about f. F prime is a function. How do we know if it's going to increase or decrease? Well, that's going to come from the derivative of f prime, which is f double prime. What is f double prime at 2? We know that is negative 0.25, which is less than 0. which means we would expect the derivative to be decreasing. So because of that, I could say that f prime of 2.1 is most likely to be less than 1.5. And that is all because f double prime of 2 is a negative number. And finally, part D, we want to sketch a graph of y equals f of x near this point and include a graph of the tangent line. So in part A, I started doing this just as a way to illustrate what's going on around this point. So let's take all the information we know about what's happening at x equals 2. So at x equals 2, we are told the y value. So let's graph that first. The y value is -1, -2, -3. We know this point exists on the graph. We also know that the rate of change is, f prime is 1.5. So if I draw a little tangent line here, that's going to have a slope of 1.5, which, let's say it looks like that. Let's say that is a slope of 3/2. So we know that the tangent line at that point is going to have that slope at that point. Now, so we've incorporated f and f prime and f double prime. F double prime is negative. That means that even though we have a tangent line, the slope of the tangent line at this point is 3/2 or 1.5. We know that slope will be decreasing in this neighborhood. So to the left of this point, I would expect the slope to be even steeper than 3/2. And to the right of that point, I would expect that slope to be shallower. So I believe this is an acceptable graph for what's going on around this point. And since we don't have any more information, we can't really graph too far beyond, outside the neighborhood of x equals 2.